Hello everyone, welcome to today's session. I am Ramesh, working as an assistant professor in the Department of Aerospace Engineering. In today's session, we are going to discuss in the subject mechanics of solids in aerospace engineering, in which the topic we are going to cover is mechanical properties of the engineering materials. Mechanical properties of engineering materials, we should have a brief introduction about that. Mechanical properties of the materials are the that describe how a material behaves under various types of force, the suitability of a material for different engineering applications. These properties determine the suitability of a material for different engineering applications such as construction, manufacturing, transportation, and aerospace. Understanding these properties, it helps the engineers to select appropriate materials that can withstand stress, strain, and environmental conditions during the service. The properties we can have it. First thing is strength. Strength is the material's ability to withstand the deformation and failure under external loads. It is one of the most important mechanical properties. Strength can be classified into several types. One is tensile strength, compressive strength, third one is the shear strength. In tensile strength, the resistance of a material to breaking under tension. For example, steel has a high tensile strength, making it ideal for bridge as well as the buildings. Next one is compressive strength. It is also the ability to withstand the loads to reduce the size. Concrete is known as high compressive strength. Third one is shear strength. It is also the ability to resist the forces that cause the material layers to slide against each other. Rivets and bolts are designed considering the shearing strength. Next property is called elasticity. We all know what is elasticity. Elasticity refers to the ability of the material to return its original shape after the removal of the deforming the force. Materials like rubber exhibit high elasticity, while materials such as cast iron are elastic. The modulus of elasticity, that is called Young's modulus, quantifies this property and is a key factor in structural engineering. Third one is plasticity. It is the opposite property of the elasticity. In elasticity, the deformation is called temporary deformation, but in plasticity, it is called permanent deformation. So, it is the ability of the material. There is a plasticity is the ability of the material to undergo permanent deformation without breaking after the yield point is passed. It is essential in processing like forging, rolling, and extrusion. Ductile materials such as copper, aluminum exhibit good plasticity. Next property is called ductility. Ductility is a material's ability to be stretched into wire. It is measured by the material's ability to undergo tensile deformation before rupture. Highly ductile materials can also be drawn into wires such as gold, silver, and copper. Ductility is an important factor in metal forming and safety under overload conditions. The next property is malleability. It is the ability of a material to be hammered or rolled into thin sheets without breaking. This property is crucial for sheet metal forming and it is different from ductility. Gold, aluminum, and lead are examples of malleable materials. Next is toughness. Toughness is the ability of the material to absorb energy and perform plastically before fracturing. It is a combination of strength and ductility. Toughness is a combination of strength and ductility. So it is important in applications where materials experience sudden impacts. Choppy and ISO tests are used to measure the toughness values. Next property, we can go and look on that hardness. It is the resistance of the material to abrasion, scratching, and indentation. Materials with a high hardness are used for cutting tools and wear resistant surfaces. Hardness is measured using various scales such as Brinell, Rockwell, and Vickers. Next property we can move on to that brittleness. Brittleness is the tendency of a material to fracture without a significant deformation. It is very important. It is the tendency of a material to fracture without a significant deformation. Brittle materials such as cast iron and glass break suddenly when stressed. That means if loads are applied, tensile loads are applied. Though not desirable in many structures, brittleness can be useful in controlled braking applications. That means using windows glass. Then another property called creep. It is the slow, continuous deformation of a material under constant stress over a long period, especially at high temperatures. Materials like plastics and metals at elevated temperatures exhibit the property called creep. Turbine blades and engine parts must be creep resistant. Next property is fatigue. Fatigue is the weakening of a material caused by repeated loading and unloading cycles. Even when the stress is below the material's ultimate strength, this is critical in components like aircraft wings, automobile axles, and bridges. Fatigue failure is sudden and without much warning. Another property called resilience, mainly it is found in springs. So it is the ability of the material to absorb energy when deformed elastically and release that energy upon unloading. It is measured by the area under stress strain curve up to the elastic limit. Rubber and spring steels. Rubber and spring, that is steel springs, are highly resilient. Next property called stiffness. It is also used in springs generally. So stiffness is a measure of the material's resistance to deformation, that is elastic deformation here. A stiffer material will deform less under a given load. For example, steel is stiffer than aluminium. Stiffness is important in applications where deflection must be minimal, such as in machine tools or precision instruments. Next property is called torsional strength. In the property torsional strength, it is the ability of the materials, the ability to withstand twisting loads. It is essential in parts like shafts, gears, and couplings. Materials must be selected based on their torsional properties to avoid rotational failure. Next one is impact strength. Impact strength is the capacity of a material to resist sudden forces or shocks. Materials used in helmets, bumpers, and protective structures require high impact strength. It is measured by the energy absorbed during the fracture under high speed loading conditions. So these are all the very important material properties we have discussed in most of the engineering materials. That's all in today's session. We will focus on another important topic in the next session. Thank you all.